we are a company which is based on quantum cascade laser solutions. So we are doing our own quantum cascade lasers. And as you know, quantum cascade lasers are mid-IR, so microconductor lasers able to address the full mid-infrared range. So what we usually call the mid-infrared is for us 3 to 20. Everybody has this definition. I just stressed the 20 because, as you will see, with these lasers, and this is quite unique in the field of quantum cascade lasers, we are able to go up to 20 micron with our lasers. So we can really fully cover all this spectral range with our lasers. What we can address with these technologies, I mean, we all mentioned about gas sensing, so either air quality, worker safety, process control, greenhouse gases, but also we can go to more complex molecules like healthcare, like glucose, ethanol. And one of the main applications of these lasers today is to protect against missile with airborne protections. And these lasers are able to emit quite a lot of power, as you will see, in order to fulfill this application. So mirSense in this field is basically as a unique low-cost technology able to follow on volume if necessary and can cover the broad spectrum range even above 10 micron with innovative solutions. So we have 3 sites. One is in Orsay, where we do laser manufacturing, optical systems, electronics and software, and laser customer support. We have one new site in Grenoble where we manufacture our sensors, and I will show you the gas sensor we do with our lasers. And we do have a site in Montpellier for the physics modeling and the laser chip development. So basically, in terms of material, and this is what is a bit unique with our technology, is that we, of course, use the indium phosphide-based material to cover the 3 to 10 micron region with the QCLs. However, when we're going to go higher, we have to change the material, and then we go to antimonide-based material with, where we can go up to 20 micron. So substrate is indium arsenide, but on the top you have antimonide-based material, aluminum antimonide, indium arsenide. So with this super lattice, you can do quantum cascade lasers above 10 micron. So in the company, we are vertically integrated, as I said. So we go from the layer sequence modeling to the module delivery. So this is like a typical high heat load laser module, which can be either for high power application or for spectroscopy applications. We do have 2 clean rooms, one in Orsay, one in Grenoble right now. And as you see, all the lasers we do are done using MB, either on indium phosphide or on an indium arsenide substrate. Just mentioning that it's always nice to say we are ISO certified, not only 9001, but also 9100, which is higher class of certification. So if you want to have our components being used in aerospace or our modules, they are qualified for military and aerospace applications. Okay, so this is the first product line that we do have, which is the PowerMir product line. It's basically a high power laser module. So you can have it either as a chip, as a module with a lens inside, with electronics, or even in a turnkey system. And very interesting is that the output beam of these lasers can be totally circular, and this is embedded in the chip. That means that it's very robust towards any vibration, thermal management issues, because this is the output beam of the chip, which is totally circular. And with this, we are able to have power above 1 watt at 4 micron, 4.6, and 9 micron, which are the main band of interest to go through the atmosphere. Typical beam divergence are in the 2.5 millirad region, which is suitable for a lot of application. Of course, we can do some beam shaping, change it for custom application, but this is the standard product. Just to give you an idea about the performances, the wall plug efficiency, as you know, quantum cascade lasers are the best in class in terms of wall plug efficiency. These are 2 graphs here to show to you why. On the left is for low power sources, so basically up to 250 milliwatts average power. In that case, we have wall plug efficiency above 15% in the low wavelength range, and around 7-8% in the long wavelength. This is direct conversion from electric to optical. There is all intermediate taken into account here. So it's really the full wall plug efficiency of the system. And when you go at higher power, and here, for instance, you see that we can reach above 3 watts of average power at 4.6. We still keep very high waveplug efficiency, close to 10 microns at 4 micron, above 15 at 4.6, and in the 4 to 5 micron percent at 9 micron. So that makes it very efficient sources. So you can use this waveplug efficiency either for extracting more heat or for making portable low energy application where you need mid-infrared. If I go to the second product line, which is the lasers for the gas sensing, housing is the same because when you want to extract quite a lot of heat, of course, we can do custom packaging for people who want to have smaller, more cost-effective packaging. This is like more off-the-shelf package. In that case, we can go up to 17 micron. And in terms of product portfolio, we do propose pulsed operation QCL from 4 to 10 micron. There exists 4 to 10 micron continuous wave QCL on the market. So we are not competing with this one. There's a lot of offers for that. And then on the 10 to 20 micron, we can either offer CW or pulsed in the 10 to 17. Since we are the only one to be able to do that, we do CW. And above 17 micron, it's only pulse QCLs. Pulse means you have small pulses of a few hundred of nanoseconds, for instance, with high rep rate. So it's quasi CW. It's not CW, but it's quasi CW. And we can go up to 20 micron. This is type of performance of the laser, threshold about 3.3 amps and powers a couple of tenths of milliwatts. Okay, in terms of wall plug efficiency for DFB, so the laser for single frequency, we are talking about few percent. Of course, we can improve this one, but this is just the off-the-shelf components that we have. Couple of percent of wall plug efficiency, which is very high, as you can imagine, because if you compare it to a thermal source, this is all the power is inside less than a wave number. So all the power you need is exactly targeted your gas line. So it is very high brightness and very high power for high wall plug efficiency. These are examples of lasers at longer wavelengths, 18 microns, for instance, with continuous wave up to 18 microns. This is the world record that we have, and we can deliver such laser if necessary. Okay, and then as I said, we've put our own lasers into a gas sensor. And thanks to the pulse operation, we can do very efficient gas sensors, compact. This is a view of our gas sensor. It's like 10 centimeters by 10. It's like a cube of 10 centimeters of size. And this is and it's based on photoacoustics. So we don't use optical detectors as it was presented today, but we use microphone to make the gas sensing. You basically shine the gas with the laser. The gas is going to vibrate and create sound at the modulation frequency of the laser. And then you listen to the sound and you get a signal. And this allows us to go to ppb level sensitivity for most gases. The sensor is here. It's very easy to integrate. So you see the sensor, you see a suitcase, in a typical case you can put on your back. So it's rather small. Everything is inside. You just have to connect with Modbus and you get the gas concentration from the system. So it's very robust for integration. You can have the ambient temperature ranging basically like from 0 to 50 degree, no problem, because with this laser we can operate the laser at temperature as high as 60 degrees, no problem. This is type of example of response. You don't see it's very, the accuracy is very good as well. You don't see the line which is the basically targeted concentration and the one which is the measured concentration. These are examples of molecules we do detect with our lasers, but of course we can do a lot of more of these ones. So all the gas line here exist at the laser level, and if there is an interest as well, we can develop sensors for markets that need such sensing technology. Okay, and that's the contact for these different components. So if you're interested in a laser, you can contact Adrien with our sales rep for the lasers, and can contact Laurent with our sales director in charge of the sensor business as well for photoacoustic sensors for the gas you want to measure. Thanks for your time.